So, I bet you've all heard the news. This is super amazing. We have found an antidote for coronavirus. The antidote, oh, yeah. Same old story, huh? Let's just call it play to win quarantine. What's this? So we are faster than 100%. The antidote is coding interview questions. Hi guys, this is Andy. Welcome to Algopedia. Coding interview question Monday. Let's get it started. First of all jokes aside, this period is going to be a little bit tougher because this is something that I won't say that humanity hasn't seen it before or something like that, but we, at least the younger generation, haven't. So let's just call it play to win quarantine. House robber, here we go. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given a list of non-negative integers representing the amount of money of each house, determine the maximum amount of money you can rob tonight without alerting the police. This is getting serious, and when problems like this get serious, I'm going to need my drawing tablet. I'll be back. Done. It's time for Picasso on its work. And here it is, guys. Just take a look at this. I think it's simple perfection. 4 houses, different colors. Look at that structure, look at that drawing skills. I should be an architect, not a software engineer, but yeah, after the virus goes away. So, 4 houses, each of them has a number, a sum of money, right? 1, 2, 3, and 1. You are the robber, so you can't rob 2 adjacent houses. And what are our choices here? Well, I could go and rob the first house. But if I rob the first house, I can't rob the second one. So then I have to choose, should I rob the first and the third houses, or the first and the fourth house maybe? Or I could leave the first house as it is, I could start robbing the second house, and after doing this, I can either move to the fourth one or not rob any of them, right? Because if I rob the second one, then I can't rob the first one or the third one. So basically here I have 2 choices to make. I will either rob the first and the third houses, or I will rob the second and the fourth houses. And what is the greatest sum? Well, 1 plus 3 is 4, minus 2, that's 2 quick maths. Alright. A big shout out to our favorite rapper, right? So 1 plus 3, 4. Or 2 plus 1, 3. 4 is greater than 3. So for this example, the answer is 4. Let's take another example. And let's jump into the second example. Again, same perfection at drawing. So we have now 5 houses, right? 2, 7, 9, 3, and 1 are their sum of money. Now, we have to choose here at most 3 houses. So let's suppose I chose 2 houses, right? If I do this, what are the houses that I can choose? Well, let's say if I choose this 7, for example, now 2 and 9 are blocked. So I have to choose 3 or 1, and I'll obviously choose the 3, right? Because it's greater. Alright, so I have a possibility is to get 10. But let's say I chose 9. When I do this, I can choose it with, well, 7 and 3 are now locked. So 2 or 1, or maybe both. Why not both? So here I can choose 3 houses, and they are going to be 2, 9, and 1. And I think this is getting a little better, right? Because this sum is now 12. Do I have any better choices than this? Well, not really. So the answer is going to be 12 for this example. Now, hopefully, you've understood the examples and the problem, So it's time for the real business. Let's try to solve this problem using dynamic programming. Yeah, you heard it. I said dynamic programming. Let's do this. Alright guys, so dynamic programming. Here are the houses, right? And we are basically the robber, which is a guy. Let's draw the guy, right? We are this robber. Now, what we can do in this dynamic approach? Well, my bulletproof formula is something like this. On step number 1, I am going to decide what are my subproblems. Initially, I have all these houses, which are n-1, right? So this is basically like the bigger problem. This is the full problem, right? Where I have the houses from house number 0 as index to house number n-1. But the subproblems are going to be houses starting from house number 0 and going all the way to house number I. Because at some moment of time, if I am this little guy, this robber, I will basically start from the first house, and I'm going to know from the start what's my plan and how I will rob the houses. So at some moment of time, I go, I will be right in front of house number I. So, step number 1 is to define our dynamic programming. And let's actually try to draw it here because I have more space. So for step number 1, as we said, the subproblem first I houses, right? So I'm going to have something like dp of I. What is the maximum amount of money, right? So max money I can take from the first, oh, my handwriting is terrible, but does the job. So, alright, perfect. dp of I is the maximum sum of money that I can take from the first I houses. Now, after I have the dynamic programming defined, I am going to need a recurrence relation. So this is step number 2. So, I'm going to need a recurrence relation for dp of I, alright? So let's say I am this little guy, and now I am right in front of house number I. Yay! Now, when I'm in front of this house, I basically have two possible options. I can either rob it or ignore it and go to the next one. What shall I do? Well, I should analyze both the options and choose the one which gives me the maximum amount of money, right? So let's see what are the options in terms of recurrence relation. Well, when I try to compute dp of I, first option is to rob house number I. So I enter, I take all your money, and then, alright, those are the money, and then I run away to the next houses. Great. But in order to be able to rob house number I should know for sure that I didn't rob house number I-1, because these two are adjacent to each other and I'm not respecting my plan. So I rob house number I. So this means I'm going to take, I don't know, let's call it V, right? V of I, which is the amount of money in house number I, but I have to make sure that I didn't rob this house. So all the money that I can take in addition to this is only from houses starting at position 0 and ending at position I-2. So this is V of I plus dp of I-2, which is great. Now, the second scenario is if I ignore this house, right? So I basically have no business here. That was me, now it's not, right? This house remains as it is. If I don't rob this house, well, how will I get the money from the first I houses? Obviously, from the first I minus 1 houses, right? So all the money that I've got by now remains the same. So dp of I is going to be equal to dp of I minus 1. And that's it. Remember, scenario number 1, I rob house number I. I'll make sure that I didn't rob house number I minus 1. For this, I need this dp. Scenario number 2, I don't rob house number I. So my money are from the first I minus 1 houses. Because I want to maximize the amount of money that I steal, of course, I'm going to choose the maximum between these two options. And that is basically my recurrence relation. Step number 3, I choose the order in which I will compute these dp's. And the order here is obvious, because when I compute dp of I, I'm going to use dp of I minus 1 and dp of I minus 2, right? So these two are states with the I less than my current I. So what I'll basically do is that I will compute this dp array starting from position 0, going all the way to position n minus 1 in increasing order. After I do that, what is going to be my answer? My answer is always going to be dp of n minus 1. So after I have completed going through all the houses and making a choice, I basically have all the money. These are the money. Alright, that's good. And I can go to some beautiful place where it's sunny and I don't know, I'm going to drink some cocktails, right? So this was the problem. Basic dynamic programming, really nothing special, but my skills of drawing and explaining things are getting really on point. So let's go on LeetCode and code it in C++. First thing we are doing is defining the dp array, which is a vector of integers dp of size n. But who is n? I need the n. Int n equals num.size. If you hear something special or different, it's my fridge. Yeah. So yeah, make sure you hit the like button, make sure you hit the subscribe button, make me famous so you won't hear my fridge in the next videos. So I have money for a studio, a real one. But until then, let's have fun, man. This is the journey. So dp of n, and let's say it's initially 0. And alright, now let's first initialize dp of 0, because as we have seen in the recurrence relation, dp of I depends on dp of I minus 1 and dp of I minus 2, which is quite bad. Like if I want to compute dp of 0, I'm going to use dp of minus 1 and dp of minus 2, and I don't really have those positions, do I? So that holds true, I guess, for dp of 1 too, because I can access dp of minus 1, and that's not cool. So yeah, let's initialize both of them. dp of 0 means from the first house, right? So what I'll do is I'll take the money, but the problem is here that, let me check if all the numbers are positive, because if they are not, that's not cool at all. Like I can lose money if I decide to rob a house, right? So certain amount of money given non-negative integers. Perfect. So dp of 0 is nums of 0. Then what is going to be dp of 1? Well, here I have two houses, so I'll make two choices. I either rob first one or second one. I can rob both. So dp of 1 is going to be the maximum, let me type nums here, maximum between nums of 0 and nums of 1. Then I will start with I from position 2 all the way to n minus 1 I plus plus, and dp of I should be equal to the maximum between dp of I minus 1, right, and dp of I minus 2 plus nums of I. So those are the two options, and now everything is good because I can't access elements with negative indices. And of course, as we said, we will return here dp of n minus 1, right? Let's see how I do. Judging. Oh, I have accepted on the example. Let's hit submit. Fingers crossed. Come on. Oh, yeah. Same old story, huh? I guess the story continues, yeah. I always, like, I have a tradition, always happens to me, like, every time I try to solve a LeetCode problem, every time I get this error. Well, I guess I have to learn my lesson someday, but not today. So yeah, basically what happens here is that our vector could be empty, of course, because why not? Like, I'm a robber and I go to an empty place where no people live and I want to rob, but yeah. And I'll end up robbing my house instead. So yeah, if nums.empty, this is how we check if a vector is empty. What should we do is that we basically should return 0 and that's all. So submit again. Let's see how I do. Fingers crossed. Oh, another runtime error. Oh, that's a new one. All right, I'm getting a bit rusty here. That's right, because what we do here is that, oh yeah, that's nice. That's actually pretty nice, because I initialize now dp of 0 and dp of 1. There's another error that I didn't expect, and that is, if the size of this vector is 0, I got it handled. But if it's 1, I can't access this element because it doesn't exist. So what I should do here is that if this is empty, alright, return 0. If nums.size equals 1, I should return the first number. Then, if, oh, the first number is 0, yeah. And if it's at least 2, then everything should be fine. So now, voila, it should work as a charm. What's this? So we are faster than 100% of the submissions in C++. And we use less memory than 100% of the submissions in C++. That's just amazing. That is just amazing, man. Nice. Anyways, if you enjoyed this video, make sure you hit the like button. Make sure you subscribe, stay tuned, because we are continuing the Play to Win quarantine. Stay safe.